Question 4. Colour solutions of X and Y react to form an orange solution of Z according to the following equation. 1 mole of X and 2 moles of Y makes 1 mole of Z. A student added a solution containing 0.5 moles of X to a solution containing 0.5 moles of Y. After 30 seconds there was no further change in colour, probably because the reaction has finished then. The amount of Z at equilibrium was 0.2 moles. Deduce the amounts of X and Y at equilibrium. Well, you're best setting it out like this. Write the equation out, and underneath each one, underneath of X and Y and Z, put the amounts at the start. So there's 0.5 moles of X, 0.5 moles of Y, and no moles of Z yet. Then you mix them, and you work out how much is formed or how much is used up. It tells you that 0.2 moles of Z is made. Now 1 mole of X makes 1 mole of Z, so 0.2 moles of X would make 0.2 moles of Z. In other words, 0.2 moles of X would be used up. 2 moles of Y makes 1 mole of Z, so 2 times 0.2, which is 0.4, 0.4 moles of Y would make 0.2 moles of Z, so 0.4 of Y is used up. So how much is then at equilibrium? Well, you started with 0.5 moles of X, you've used up 0.2, you've got 0.3 left over. Y, you started with 0.5, you used up 0.4, you've got 0.1 left over. Z, you didn't have any to start with and you've made 0.2, so you've got 0.2. On the grid below, draw a graph to show how the amount of Z changed from the time of initial mixing until 60 seconds had elapsed. Okay, so what you've got to do is you've got to label each axis. So you've got to label this one moles of Z, going up to 0.2. So start at 0, maybe go 0.05, 0.1, 0.15, 0.2, maybe 0.25, something like that. And then along the bottom it says for 60 seconds. So you're going to go 10, 20, 30, 40, 50, 60 seconds. And then you're going to draw a graph, and the graph will increase and it will go up to 0.2. So if you've got 0.05, 0.1, 0.15, 0.2, let's say, it's going to come up to here after 10, 20, 30 seconds. It's going to hit that point there and then it's going to level off. So it'll go through 0, it'll come up and it'll start to level off, and at that point there, which is 0.2, it's going to flatten off. The student prepared another equilibrium mixture in which the equilibrium concentrations of X and Y were 0.4, so X and Z were 0.4 and 0.35. For this reaction you're given an equilibrium constant. Calculate the concentration of Y. If you're given an equilibrium constant, you need to first of all write an expression for the equilibrium. The expression for the equilibrium constant is Kc equals the concentration of Z divided by the concentration of X divided by the concentration of Y to the power 2. So it's going to look like this. Square brackets mean concentration. Then what you can do is you can rearrange. So I'm going to take Y squared from the bottom on this side to the top on the other side. Then I'm going to divide both sides by Kc and take Kc down onto the bottom on the other side. So now Y squared equals Z divided by X divided by Kc. If you put the numbers in then for Z and X and Kc, 0.35 divided by 0.4 divided by 0.29. And then if you square root it, so that's Y squared, square root it, Y will be 0.55. The student added a few drops of Y to the equilibrium mixture, so added more Y. How would the colour change? Suggest how the colour of the mixture changed. Give a reason for your answer. So they're adding more Y. So let's go back to our mixture here. If you're adding more Y, by Le Chatelier's principle, it will try and oppose that change and try and use up the Y. So if you add more Y by Le Chatelier's principle, it'll try and use up the Y, and it'll use up the Y by shifting the position of equilibrium to the right hand side, using up the Y and making more Z. Now it says Z is orange in colour, so the colour is going to darken or get more orange. And the reason is the equilibrium moved to the right to oppose the increased concentration of Y, to use up some of the Y. The student warmed the equilibrium mixture. Predict the colour change, if any, when the equilibrium mixture was warmed. Well, let's have a look back again then. Right, the reaction is minus 20 kilojoules per mole. It's exothermic. That means it's exothermic going in the right to the right. So when you make Z, it's exothermic. In the reverse direction, when you make X and Y, it's endothermic. It would take in heat. So if I provide heat for it, it says here, what would happen when the student warmed the equilibrium mixture, so provided heat. So by Le Chatelier's principle, the equilibrium will shift to try and reduce the amount of heat, oppose the change, and lower the temperature. And it would lower the temperature not by going to the right-hand side, that's exothermic, by going to the left-hand side and lowering the temperature of the surroundings. These are colourless, therefore the solution would start to fade in colour.